is fun. I mean, they have to have a little tail. And, you know, kind of fun. But this is what a kite looks like. Typically, you've probably seen kites more drawn like this. I mean, it's the same idea. It's just, it's easier to fit it on the page when they're sideways. So yeah, some things that are not marked on here, but they are marked on here. But let's be honest, how many of you guys are actually going to look at this stuff down here and read it? Probably none, which is fine. Well, maybe one. Some people probably will, hopefully. It is helpful to. I am going to point some things out, so maybe it will, like, encourage you to look at it and see things. Things like this, like EC is congruent to EA. That's not marked up here. But it is cut in half. So only one of the diagonals is bisected. One diagonal is bisected or cut in half. EC and EA. Then you've got like two pairs of congruent consecutive sides. So that consecutive meaning they're like next to each other. The opposite sides are not congruent for kites. And that kind of throws people off at times because it's a little bit different. The diagonals are perpendicular, so you're going to have right triangles. We are going to use Pythagorean theorem today. So like that Pythagorean spiral that we did and talking about Pythagorean theorem, you've already seen it before. Hopefully it makes sense for what you're doing now. Okay. One last thing that's written here, that's not on here, we're actually going to write that in, is you see where it says that it's this one. CDE. So like this angle right here is equal to this angle down here. CDE is congruent to ADE. Alright, we're going to mark that because this diagonal, so the diagonal that does not get cut in half, the longer diagonal, typically it's the longer, will cut the angles, the opposite angles in half, which is confusing. But if you kind of look at it, it makes sense. Like these angles look the same. It's like you can fold this in half. There's a line of symmetry where you can fold it in half, therefore these angles are the same. Here you can't really do that. See how that angle on this side is smaller than this angle on this side? So those are not the same as each other. But these angles as a whole on the top and bottom. Kites really just, there's just a lot of information. Okay, kites can be a little bit challenging, but it's really, just think of it as just like a big puzzle to solve. Okay, let's take what's listed up here and let's write this on this kite. AC is 10, so let's write that in, but I don't actually want to write it in. I'm going to write it in the halves because EC is 5. See that there? If EC is 5 and the whole thing is 10, that means both of these are 5 because this diagonal gets bisected or cut in half by the other diagonal. ED is 12. All right, ED is 12. And then ADE. All right, I want you to like do some thinking right here and not just write down what I'm writing. A, then D, then E. So find this. A, D, E. So it's this bottom angle here. It's the space in between AD and ED. So that is 23 degrees. And then ABC. So this entire angle. So see the difference between ADE, it's just this half, and ABC is this whole angle right here. So both of these put together. So instead of me writing 86, I'm actually going to write 43 and 43. Why am I doing that? Because I am going to take 86 and cut, 86 and cut it in half. Make it so where you can see it, which is 43. So each of these is going to be 43. Okay, let's solve for some of this stuff. So we're going to do some Pythagorean theorem first. CD is the length of this side right here. So things that I want you to notice. I want you to look at this picture right here and you're like, okay, this is a right triangle. We're going to do some Pythagorean theorem. We did this on that project. You guys did fairly well on that project. Let's just, hopefully we understood what was going on. I'm going to write a squared plus b squared equals c squared. And I'm going to take 5 squared and 12 squared. And we need to solve for that hypotenuse. All right, why am I plugging them in like that? Well, because these two touch the right angle, so it's A and B. C is across from the right angle. It's the longest side, so it's going to go over here. And that's what we're looking for. And then I just take my calculator. I do 5 squared plus 12 squared in the calculator, and I get 169. And then remember, my last step is to always take the square root, which in this case is going to be a nice pretty whole number, or 13. So CD is 13. All right, if CD is 13, can anyone in here tell me what AD will be? Yeah, the same thing. Okay, so if you were like, where are they getting this? Look at these two little markings. This is 13, so is this. So once you find this, it unlocks AD. Both of those are 13. Okay, let's look at AED. This one is pretty simple if you realize that, and I'm going to go up here, the diagonals are perpendicular. So these are like the properties of a kite. There are perpendicular diagonals, or they create right angles. So all 4 of these are 90 degrees. Okay, that hopefully is pretty easy. You just have to be able to identify the actual shape. AED. 90 degrees. All right, let's look up at CDE. So that top angle right here. I'm going to sneeze. All right. So if I look here and then I look up at this shape above. So this one's 23. I've got to figure out this angle up here. CDE. Bless you. So here, these two angles are the same. How do we know that? Because the one pair of opposite angles are congruent right here, and then the diagonal bisects the angles. So this one's 23. Voila, so is that one. 23. All right, and then CDA. So this big angle over here. All right, I've got CDA, and we know that this one's 23 and this one's 23, so we can figure out the whole thing just by adding them together. Oh, I can't see that. Add them together. 23 plus 23 is 46 because it adds them together. C, then D, then A. So basically, this is a pretty easy, like, concept, all of this, if you know how to, like, identify angles. If you struggle with identifying what angles it's asking for, that's something that you're going to need some practice with. So you just follow the letters, and it's the space in between those letters. C, D, A would be the space in between C, D, and D, A. That's what an angle is. All right. B, then C, then D. Okay. This is what gets difficult. So if you have stopped listening, this is the time to listen right now, because this is really going to help you, and this is the most challenging part of the angles in kites. Okay? We need to figure out this whole angle, which the way I'm going to do it is I'm going to just solve for these two separately and then add them together, because you have two 90-degree triangles right here, and I think this is the easiest way to do it. So we've got these three angles that add up to 180 degrees because it's a triangle. Okay? So 90 plus 23, and then subtract that from 180. So we add it, well, that got a little crazy, but it's still 90 plus 23 is 113. Subtract that 113 from 180, and you get 67. This we've been doing all year long. It's nothing overly complicated. This plus this equals that. Or this plus these three angles add up to 180. And you're going to do the same thing for this over here. This is also a right triangle. So 90 plus 43. Subtract that number, those numbers from 180. 47. 43, 47, and 90 add up to 180. And then you want the whole thing, so you're going to add them up together. 47 plus 67 equals 114. Okay, there's one other way to do it. If you'd prefer to do it this way, and it's fewer steps, but, you know, you can do it if you'd like. If you treat this triangle as a whole, so like this top angle as a whole, it basically act like this line's not here. 43 plus, no, 43 plus 23 plus this entire angle also add up to 180. So if you take 23 plus 43, you get 66. 180 minus 66 is 114. So it's literally like the same answer. This, like, cover this bottom half up, acts like this line isn't here. This plus that whole thing. Same thing. All right, let's go to the next page. All right, I went ahead and labeled the sides that are given. things that, you know, we need to see. It asks for EA first. So if you're looking, you're like, oh, this is 6. This is also the same thing. Things that I don't want you to get confused. Some people, they look at this and are like, oh, all 3 of these are going to be the same. That's not always the case. Notice this one's 5 and these 2 are 6. This diagonal gets bisected. This one is just, it can be a different number. So don't overthink it. All right, now we're looking for ED. So we're looking for this angle right here. This gets a little tricky. I want you to write a squared plus b squared equals c squared. And then I want you to try to solve this. Okay, so a lot of the ones we've been doing recently have just been like adding 6 squared plus 12 squared. If you do that, you're going to get like 13 something. This side is shorter than 12. So that won't work. So what you've got to do is subtract 6 squared on both sides. So you end up with like 12 squared minus 6 squared. You get 108. And then you take the square root of both sides. And we are not going to simplify that square root. We're just going to have it as a decimal this time. I know we did a lot of simplifying square roots. We'll do it more next semester. We're not going to do it today. There's plenty of other stuff to be done. So you got 10.4. But I just want you guys to make sure you see, like, okay, sometimes you're going to subtract to solve. Sometimes you're going to add to solve. In this case, you're going to subtract because you're given the hypotenuse. All right, AD. So we have CD is 12. AD is also going to be 12 because these 2 are the same. So make sure you guys can see that. Those 2 are the same. These 2 are the same. So 12 for AD. Now you're looking for BC. So for BC, you are going to use Pythagorean theorem to solve. Again, 5 squared plus 6 squared. Probably getting tired of Pythagorean theorem by now. But hopefully you're getting good at it. And you get 61. So in your calculator, you just need to do the square root of 61. And that will solve. Oh gosh. So square root of 61 on both sides. 7.8. So if this is 7.8, so is this, because kites are nice and end up equaling the same thing. All right. So what I want you guys to do is get that worksheet out, and we're going to look at a couple of problems together.